Hi, my name is Scott McDaniels. I'm the head of the prototype shop part of engineering here at Vans Aircraft, and we're doing this video to just give a general overview on the assembly processes of an RV fuel tank to supplement what's in the construction manual and just fill in some of the details that might be helpful to some people. So we have laid out here all of the parts for an RV8 fuel tank, which are going to be representative of most any of the riveted fuel tanks on all the RV models with the exception of the RV12. But even in a lot of instances, what we do here in showing examples of use of the fuel tank sealant will even be relevant to that somewhat. So leading up to this point, we're not covering all of the prep details because that's pretty self-explanatory, I think, but I will cover a couple details of how I do it specifically that I think it simplifies the process a bit. So in the construction manual, we detail scuffing all of the surfaces that are going to get sealant to help assure good sealant adhesion. Now I do that before doing all of the dimpling. The reason being is it assures that it's well scuffed on all of the surface of the dimple, particularly on the ribs and other parts where the dimple is a recess. And if you were scuffing once the dimples were made, it's difficult to scuff down into the dimples. So if you do that before the dimpling is done, then you're sure to have all of that surface dimpled well. So I scuff before doing any of the dimpling, and then I clean the parts well before starting the dimpling, because Scotch-Brite pads leave a lot of material behind, and you don't want to be driving that, into the surface of the material while you're doing the dimpling process. We'll do another cleaning just prior to installing a part with sealant applied, just to make sure there's been no contamination since the initial scuffing was done, contact from bare hands, that type of thing. But it'll be a real simple cleaning process then, because most of the residue from the Scotch-Brite pads was removed previously. So the very first steps that we're going to be doing is installing some of the ancillary parts on the skin, which is going to be the flange for the fuel cap, which has been pre-prepared by machine countersinking to accommodate the dimples in the skin. The flange for the quick drain, which mounts over here at the aft inboard corner of the skin on the outside. A doubler flange on the inboard root rib where the access cover mounts for gaining access to the interior of the tank if it should ever be needed. And the fitting in that rib that accommodates installation of a fuel vent line on the interior of the tank. So those will be done in advance to doing any major assembly of the tank. Okay, so we're going to get going with the installation of our first parts, but wanted to cover a couple of other details just a little deeper than we have at this point. For cleaners, a wax and grease remover type cleaner that's used for paint prep is a good choice for cleaning the parts for sealant application as well. There's not a specific product to use. Any of them that's sufficient for paint prep will work. There are other solvents that work well as well, such as naphtha, commonly known as Coleman fuel or white fuel, for anybody that's familiar with that from years ago, not so popular now. Be aware that most of these aren't a super fast drying solvent like acetone is. So you don't want to be wiping down parts and then starting assembly just 1 or 2 minutes later. You should, give it a little bit of time to be sure that it's dry. Be cleaning everything until you're not getting any residue on the rag anymore. If you do follow the process I mentioned earlier of scuffing and cleaning prior to dimpling, it shouldn't take much cleaning, and that's a good thing because then whatever towels you're using aren't getting ripped up and abraded by rubbing over the dimples, because they can be a little bit rough. So sealant, the sealant that we use is mixed in a ratio of 10:1 by weight. So that's what I have here, 10 parts to 1 part. And that allows you to do it in any volume that you choose, as long as you maintain that proper ratio. Really good way to accurately mix it, which is important, is just get an inexpensive small digital scale that you can just use scraps of aluminum or coffee can, plastic lids, whatever you want to use as a surface to mix on, and just zero the scale like I did with this piece of aluminum on it, and then just add a volume of the main body material of the sealant that looks like it's going to be about right for what you want to do, and then just add 1/10 of that in weight of the catalyst so that you have it ready to go, and then you can mix it when you're ready. Okay, one of the things that I wanted to cover before we get started installing any parts is a little bit of the philosophy of sealing the fuel tank. In the construction manual, it talks in very general terms of applying sealant anywhere that fuel would leak out. And that is essentially what we are doing. But sometimes it's helpful to think about it in a little bit broader context than that. What we're really wanting to try and do, and what gives the best finish on a riveted fuel tank, is if you think about the sealing of the tank to be working from the inside out. So we're wanting the seal to take place at the most inside point that fuel would begin to start exiting, through a gap, rivet, whatever it be, towards the outside of the tank. So commonly people emphasize sealing, say, the ribs of the tanks as the seal occurring here at the dimple on the outside. We want to think of it as happening on the inside. So we're primarily developing the seal between the two mating parts, in this case, the skin and the flange of the rib. And then we're adding a little bit of extra sealant over the shop head of the rivet on the interior, just to make sure that fuel is not migrating, down the shank of the rivet and possibly through to the outside. But if you think about the way this process is working, when the rivet sets, it's drawing parts together. If sealant is in there, that sealant is encapsulating around the shank of the rivet and tightly trapped between the rib flange and the skin. And that is where the seal occurs. So we're less concerned about sealant under the rivet heads on the outside. You're gonna see me actually using a technique that reduces a lot of the mess and helps get a nice flush finish of the rivet heads by actually removing excess sealant from the dimples after the rib is clecoed in place. Now there is some tools available on the market for making deeper dimples that in essence ends up leaving a layer of sealant between the rivet head and the skin, which we consider undesirable from a structural standpoint. It's basically putting a soft layer of material between your solid rivet and your solid structure. And our preference is that the tanks be built with the rivet seated tight in the dimple, and that works just fine if there's not an excessive amount of sealant in the dimple at the time that the rivet is set. So I'll be showing a technique for dealing with that. Okay, so the first part that we're going to install is the fuel tank flange. This is the newer version that we have that's a machined aluminum flange with an inner portion that matches up to a latching cap. It is different from the legacy fuel cap flanges. The installation though is about the same, with one exception, is that because it's machined, its thickness changes around its circumference to account for the curvature of the fuel tank skin. So it needs to be installed in the proper orientation so that the thicker portions are to the lateral direction on the tank and the thin portion is towards the front and the back. So we'll be making sure that that's orientated correctly. Other than that, the processes that we're using you would use for the original legacy flange or this one. You notice I've got some tape around the interior surface of it. There is going to be a bit of sealant squeeze out towards the inside. That allows for keeping it clean and making it a lot easier to clean up and get it looking nice after the flange is riveted in. You don't want to leave sealant in there on that surface. That is a surface that the cap comes in contact with, and over time, even though the sealant is cured, with the airplane exposed to hot sun, outside temperatures that are elevated, that type of thing, it can actually make the sealant a little bit sticky and make your cap want to stick in place. So you want that entire flange or portion of the flange entirely clean once you're done with the riveting process of the fuel cap flange. So let's start by applying a little bit of sealant to this flange. Now this is going to be showing how I develop a layer or coating on pretty much any flange part in the tank, whether it's the wing ribs or this. So I just initially get a rough application so that there's a bead around the entire perimeter. And this is going to be a very excessive amount right now. One of our goals in applying sealant is to use just enough to get a seal. I know a lot of times people are, frightened of the idea of having a leak, and nobody wants to have that. But it's pretty common for an excessive amount of sealant to be used. When I'm building a tank this size, or I should say a pair of tanks, I usually use about a half of a quart can for both tanks. And it's not uncommon for people to use more than a quart. They have to actually get more to finish their second tank. So there I've got some sealant on, and now what I'm doing is with the stick tilted, I'm going around and removing excess to both sides of the rivet holes, so that all I'm going to do is leave a little bit of a peak down the center. And then to the inboard and the outboard edges, I just want a coating, but not a thick buildup. Because what you want is you want a place for the excess sealant to go as the parts squeeze together. Because if the parts fit closely, you in essence only have a few thousandths thick layer of sealant between them once the riveting is done. And if you start with an 1/8 inch thick layer of sealant as you bring the parts together, all the rest of that sealant has to go somewhere. And it just ends up making a lot of mess because the majority of it squeezes out. But there is a lot of hydraulic action to the sealant because it is sticky and pretty viscous. So the more you have on the surface when you bring the parts together, the more there is to get squeezed out of there. And an excessive amount will actually leave an excessively thick layer, more than we want. When we start getting into some of the other parts that we're assembling on the tank, having an excessively thick layer between the parts starts to build up and stack up to affect the overall dimension of the tank. The tank wasn't designed for thick layers of sealant between all the parts. It was designed for just minimal that does the job of making the seal, but nothing more. Okay, so ready to install the part onto the skin. When able, it doesn't always work, but when you're able, it's a lot easier to get something like this lined up if you can be lining it up on a cleco. So have the cleco there first, and then bring the part into alignment with it. And then try and align some of the rest of the holes before you allow the cleco to close. Okay, and then that should make it pretty easy for lining up the second one. Squeeze out on all the holes is showing that we got enough sealant in there to cover all the contact area. And you'll notice on this side, we've got all the squeeze out through the dimples. I'm going to show you what I do to deal with the sealant squeeze out on the dimple side here. So I just cut a bunch of scrap paper strips, 5/8, 3/4 inch wide, thereabouts, and just have them laying around so that they're ready. And I'm gonna actually just use it as a little scoop that you just put a fold. That one I didn't get all that well. Just put a little fold in it and scoop out the excess. It doesn't have to be perfectly clean, but we're just trying to get rid of the major portion so that when we insert a rivet, it's not going to just fill up the whole dimple and then be holding the rivet head up off the surface. Like so. Then you can just keep a trash can nearby so that you can just drop these in in, and it's easy to make more strips, so there's no point in getting really messy by having a lot of this stuff sitting around and getting all over your gloves. Okay, so I'm just going to pre-insert rivets in most of the holes. In this particular instance, because we already mentioned that the flange varies in thickness, it's going to be a couple of different size rivets around the perimeter depending on whether you're on the thicker portion of the flange or the thinner portion. So there you see the rivets are inserted. They're laying pretty flush in the dimples because there's not an excessive amount of sealant underneath the heads. So once set, we'll have a nice flush finish on those rivets. So I like to use a rivet squeezer in any instance that I have access to the rivet with one. We'll talk about a number of other places that in particular that I think it's a benefit in the future as we go through some of the other parts. But here on this flange, you can do these with a rivet gun and a bucking bar or a squeezer. If you have a small enough yoke that can reach inside here from the bottom. This yoke in particular has been modified slightly many years ago just for this purpose. But there are a lot of yokes out there that are small in size, that as long as you pre-check and verify that they'll go through the flange like this, it makes it a little easier than using a gun and a bucking bar dealing with this floppy skin. So that gets all the rivets except for where we installed the clecos. Now I put the clecos in those locations on purpose. One is that the forward cleco is where the location of the clip that retains the vent line goes. So I wanted to make sure I didn't put a rivet in that and then have to remove it because I didn't install the clip. And it also helps pull the curve of the skin tight to the flange and get it all in contact for you to start putting the rivets in. Okay, so we'll do the last two rivets here. And the forwardmost one is with the clip in place. Once we've got a part fitted and riveted in, now we want to fillet any edge of the part so that we've got a nice radius fillet in the sealant. That enhances the sealing ability of the sealant and prevent it from having leaks develop onto the edge. So the technique you're going to be using is going to depend on how much sealant is there. In instances where there's a large amount, you can take a, call it a popsicle stick, and the radius end is a good radius for doing this. But if you sand it on a sanding block or belt sander a little bit to make a little bit of a sharp tip on it, you can actually use it as a tool that will scoop away sealant when you have an excessive amount, because we're just trying to get a radius there, and I took away a little too much, so I probably shouldn't have been using it as a scoop in that instance. Leaving a radiused fillet like that is what we're after. And if you need to, you can even add a little bit. It'll join up with the sealant that's already there. Similar to that, so that there's a nice radius on the edge. So same thing on the top side, though here, because we need to allow for clearance for the fuel cap, in this particular instance, we're just trying to clean it up on that edge. So that there's not going to be any sealant on that surface that would later cause the cap to try and stick. Get a hold of the tape here. And then whatever little bit is left, you can use a little bit of acetone. Next part to be installed on the fuel tank skin is the quick drain flange. The installation process is pretty much an exact copy of what we just did for the fuel cap flange, so we won't be showing that in the video. We've got the fuel cap flange and the fuel quick drain flange installed now. You notice I've encapsulated the rivets on the back side. That's for the primary point of entry, like we talked about before, of leakage for the rivet. So if the rivets are well encapsulated, then we don't need to be worrying about sealant on the manufactured head side. So there's sealant between the flange and the skin, and then sealant on the rivets. A little trick that I'll show you that can help you get sealant applied to these. This will also work for the rib flange rivets, though it's a little more awkward because you're working next to the rib, and a longer piece of tubing is a good idea. But you can just take a piece of scrap aluminum tubing that's been deburred and finished on the end, and this sealant is starting to go off a little bit now, but this will still work. And you just get a little bit in the end of the tube, and you can just spin it over the top of the rivet, and it'll make just a little circular encapsulation coating on the rivets. Now when we start doing the ribs, obviously the web of the rib is going to be right beside there, so you need a bit longer piece of tubing that you can hold at a little bit of an angle, but it still works pretty good and can help speed up that process and make it not quite so messy. Another part that's been prepped in advance as far as assembly goes is the inboard or root rib of the fuel tank. In the RV7, 8, 9, 6, and 4, they have a removable cover that gives you access to the inboard bay of the fuel tank. The RV10 and 14 are done a little differently, so this isn't totally relevant. But for all of the others, there's a doubler ring added that reinforces the rib and has nut plates that receive screws that mount the cover plate. Now, I don't use sealant between the doubler ring and the rib because once again, we're trying to seal the primary leak path, and the primary leak path is the seal of the cover on the rib. So if when the cover is put in place, it properly seals, it doesn't matter whether fuel leaks from the outboard edge of the doubler to the inboard edge of the doubler, which is still inside of where the cover plate is. Now, with one exception, and this isn't going to be relevant to all of the models, but there is one 3/16 tooling hole right here adjacent to the edge of the ring that I use just a little bit of sealant on this tank, because when the cover gets sealed on, the edge of the cover is just barely covering the edge of that hole. So in case the sealing of that cover didn't cover that hole well, this is sealing it from the inside to the outside so there wouldn't be any leakage. So that is all of the advanced prep that's going to be done on this rib until the rib is installed in the tank skin. There's a fitting that goes here for the vent line for the tank. If I installed that now, it would be protruding inside and would get in the way for finishing the fillet and doing a nice job on dealing with shaping the sealant for that. If we installed the bracket that goes in the nose portion, it makes it very difficult to access these 4 or 5 rivets that are up in the front here. So that's also going to be left off until the rib is installed in the tank. Then we'll be coating the interior surface with a thin coat of sealant, adding the doubler that goes on the inside, which also helps seal the extensions on the flange notches there, and then the bracket will be on the outside. And that's not at all difficult to rivet after the rib is installed into the skin. The next step in the process is adding the skin stiffeners to the bottom skin half of fuel tank skin. So you see we've got the skin loaded up with rivets and riveting tape applied to keep them in place. You can use regular tape if that's all you have. This is the best choice because it's a specific tape that has no adhesive down the center. So in the process of driving the rivets, there's no risk of driving adhesive or trapping adhesive on the edges of the rivets. And it's extremely thin plastic tape and not compressible, so it won't allow the rivets to sit a little proud when they've been driven. Pretty much the same process that's used for stiffeners on a lot of the control surfaces in other parts of the airplane, with just the one exception, once again, that sealant's been added, keep fuel inside and not allow it to leak past the rivet to the outside. So we've got all the rivets in place. I did another final cleaning of the row prior to inserting them. And now we're ready to just start applying some sealant to stiffeners, putting them in place and back riveting. One other detail I wanted to point out that isn't relevant to all of the RV fuel tanks, this is particularly applicable to the early kits when builders had to make all their own stiffeners, do the layout, etc. We're looking for a fuel tank that, to the greatest degree possible, that can always allow good drainage all the way to this corner where the quick drain is. All of the ribs install in such a way that there's pretty good drainage, but there's a potential for entrapment at this inboard edge of these two inboard stiffeners. So if you're making the stiffeners yourself or have made them, before you rivet them on, you want to make sure that there is some gap here between the inboard end of the stiffener and the rib. Enough that's going to allow for forming the nice fillet of sealant once we've sealed the rib in, and then still have a path for fuel and water to get past that to the drain at the back corner. So that's something to double check before you rivet the inboard stiffeners on. So ready to apply some sealant to the first stiffener. Going to be using the same basic procedure as used for fuel cap flange, just getting it coated pretty generously. But then to get us to the point of not being excessive, gonna hold the stick tilted again and try and remove out to the edges and just leave a thick line down the center over the top of the rivet holes. Like so. And that's more than enough to get a good seal on the stiffener. So putting it in place, make sure you're paying attention to the plans, that you know which way the flange goes. It, in some cases, can be important because of potential interference with the fuel level sender float. So you want to make sure that it's installed the right direction. Put it in place. Use some pressure and wiggle it around so that we're not just relying on the rivet setting to try and get all the sealant to squeeze out. Since in this case we're not using any Clecos or anything to put any pre-tension on it. If I wiggle it around, you can see it slowly worked sealant out from under it so that we're not leaving an excessive amount there. So now we're ready to set the rivets. For every single stiffener, double check and make sure you know you're on your back rivet plate. I have a really big one here that is big enough for just about the entire skin, but not quite, so I could accidentally go off the end. But most people are using a shorter one, and it's really easy to accidentally run off the end, which totally ruins your day because it totally ruins the skin. So I like to start at the center. When back riveting, to not lay over rivets, it's very important that you're riveting very square or parallel to the rivet. So you can see the reflection in the skin really well, since the fuel tank skins and parts aren't primed, and you can use that reflection to line up the alignment of the rivet set and the gun to know when you're exactly lined up on the rivet. If the reflection is perfectly aligned with the rivet gun, then you know it's straight. There we go. Okay, then we're going to take our little piece of tubing again, just spin it in the sealant to just fill the end of the tube slightly. And that does a pretty good job of encapsulating the rivet head without leaving a real big mess. Then the only thing left to do is finish our fillet. And on the back side of the flange, because there's a pretty generous radius there, it doesn't always squeeze out. Far enough to get a good fillet, and if it doesn't, as it did here, you can work some of the material down the length, or even just grab a little bit more. On the end of the stick. Like so. Then just repeat that for all the rest of them. Pull the tape from the other side, and then you'll be ready for the next step. So continuing with the fuel tank build, we're up to the point of adding ribs. As you can see in the background, we've got a few of the ribs in the tank skin already. We've got a couple left that we can use as demo for showing the process for doing that. But before we go to that, we'll talk about the prep of the ribs before they're being installed in the tank. That's one of the really important aspects to getting good success with this, because it adds enough of a challenge having slippery fuel tank sealant all over the parts. But if you're fighting to get rivet holes lined up because the ribs haven't been properly straightened, or the flanges aren't adjusted properly so that they're right at 90 degrees, it just adds extra challenge and difficulty to getting the ribs installed. So we already talked earlier about the prep of the parts, that I do the scuffing of surfaces that need to be scuffed before I do any dimpling, so that it's scuffed in the bottoms of the dimples and it's easy to clean. So that's just a little bit of review on that. But let's take a look at the other prep work done on the rib. Now when they come out of the kit crate, they don't lay flat like this. And to be honest, when you're all done straightening via fluting and adjusting the flange angles, sometimes they will still have some twist in them. won't necessarily lay flat statically on a table like this. And that's not a reason for concern. We're just trying to get them straight along the rivet holes, but that doesn't mean it's going to necessarily lay perfectly flat on its own on a flat surface. So the process of prepping the parts, get the flange angles adjusted to 90 degrees first before I'd even do anything with fluting pliers, because otherwise things are going to change once you start changing the bend angle of the flanges, and you'll have to go back to fluting again after that. So the flange angles are adjusted first. A common mistake is people using a very small square, just checking for 90 degrees, right here adjacent to the flange, because the ribs are not always perfectly flat between the bends. This one is pretty good, but sometimes there's a bit of dip or distortion in the middle, and we're looking for 90 degrees relative to the skin between top and bottom. We don't care if it's 90 degrees to the web of the rib inside of the tank. So the best technique is to use a large square that will bridge all the way across the height of the rib, and then be checking for 90 degrees relative to that. And then you do that down the whole length of the flange, top and bottom. And this one is pretty good. So once you've done that, and you've got flange angles that are properly adjusted, then you can use the fluting pliers and start working towards getting the rib to lay flat. But what we're really after is getting the rivet lines in a straight line. Laying flat is kind of an indicator of that, but another good check is using a straight edge. And this is a lot easier to see before the dimpling has been done, because then you can accurately align with the edge of the holes. But we're trying to adjust so that the holes are all in line with each other. This one is pretty good. Maybe here in the center, they're just barely out of skosh, and that is a small enough amount that it shouldn't be a problem. It's a little trickier to check this way on a flange that curves quite a bit, because you got to be making sure that you're laying the straight edge exactly flat on the flange. If I hold the straight edge crooked, see, I can make it go out of alignment with the holes, and it's not really giving me a good indication. But if I pull it tight and make sure that it's laid flat to the flange, it will give you a really good indication of whether the flange is straight enough to have all the holes in a straight line. So once again, you don't want to be fighting with that in the tank skin, having the holes misaligned laterally because there's a bow in the rib, because with tank sealant on the parts, it makes everything slippery, and it's even much more difficult than just the rest of the airframe construction to get the rivets to set properly and for things to line up. Another reason this is important is the fuel tank is one structure in the airplane where we have a stack up of a lot of parts that can all have an influence on the fit of the tank when the tank is fully assembled, if we don't have good nesting of all those parts. Now, it's not the case for every model. The RV4 and RV6, the tanks attach a little bit differently, but all the tanks for models that followed those two have a rear baffle on the back of the rib, and then we've got what we call a Z-bracket that goes on that. So if we end up with a rib that's slightly mispositioned in the skin and is pushed aft a little bit, and then we put a Z-bracket on and it's pushed out of position a little bit. We can now have a stack up of tolerances that when we get done, the tank won't fully go onto the wing to match up the leading edge or the aft edge of the skins, because the Z brackets, they bottom out on the web of the wing spar, and that's as far as it's going to go. So another thing related to that detail is excessive use of tank sealant. We can actually get really carried away with a layer of tank sealant, especially if you're working in a time interval where you're maybe getting a little late in the workable time and the sealant is just starting to go off a little bit, becoming a little bit more viscous. It's not going to extrude out from between the parts quite as easily, and you can end up with a rib that is actually set a little bit aft in the skin, and then once again that affects the stack up of all the parts that go on after that, and can have an influence on how the tank fits. So that's something to keep in mind. I'm going to be showing you the technique that I use for applying sealant. It's basically the same thing as what we did on the stiffeners, to make sure that we've got a good amount concentrated right in the center of the flange where the holes are, but we're leaving some room for sealant to extrude out and try and end up with just a very minimal layer in between the parts once the rivets are set. So as you can see, we've got a few of the ribs already installed, and I wanted to cover a detail for order of assembly that's pretty beneficial. Most of us humans have arms to elbow length or hand to elbow lengths that are longer than the distance of one rib bay. So if I had started with this rib first and was working my way this way, anytime I was reaching to the bottom, this rib would always be in the way. So if you started the inboard end first, and that's the first rib you put in, there's nothing else in here, and you have really good access to that rib. And then each progressive one that you do, you still have the total open access outboard in the tank skin. So if you can remember that detail and start inboard, except for the inboard rip rib, and always work your way outboard, because all RV tanks, in fact, predominantly the entire wing, our ribs all install with the flanges facing outboard, with the exception of the root rib and the tip rib out on the tip of the wing. So start inboard and work your way outboard, and it will leave you really good access to the flange side of the ribs as you're installing each one. You'll notice I have a little stick of wood here on the end. It's just something with some slots cut in it to hold the skin apart for me, give me a little extra room getting the rib inserted in there once the sealant's on it. We want to try and not drag the sealant on the skin as it's going in, because that can just drag a thin spot and potentially have a less than ideal seal in that area. So you want to be able to get it all the way to the leading edge, or nearly to the leading edge, as it's starting to contact the skin. So the other detail to point out is you'll see that the only ribs that have been put in at this point are the intermediate ribs in the middle of the tank. The benefit of doing that is when the very first rib goes in, so it's just a bare skin, the skin will open up the most that it's going to for installing the ribs. So when you're installing your very first one, it gives you the opportunity to have a lot of room and kind of get used to inserting it without dragging it on either side, and then be pulling it together somewhat on the rib once it's inserted to the leading edge. Then as you work your way down the tank skin, things are going to get tighter with each successive one that you install. This last one I'm going to be putting in is going to have the tightest space for getting it in and not dragging the sealant, just because the whole thing is starting to get stiffened up and pull into what its final shape is, because all the rest of the ribs are in there. So people might be interested in knowing how much sealant they need to mix up to do one wing rib. This right here is going to be a little bit on the generous side, and we can look at it when I finish and you'll see how much is left. But it's probably the equivalent of a very heaping tablespoon, I would guess. And we will have some left over, but I consider it better to have a bit left over when I'm done than to run out and have to be trying to mix up a little bit more while I'm in the middle of a riveting session. So I prefer to just mix up enough to do one rib. I never know, especially around here, I may get interrupted and I have to go do something else, and then I waste it. And it doesn't take very long as you have the scale to do the accurate measuring. And as you can see, I just use a little bit of scrap aluminum to mix it on, but you can use just about anything, you know, throw away coffee can lids or you know, whatever you want, as long as it's a clean surface, and for me, preferably something that you're willing to just throw away when you're done. Works well. We got some sealant mixed up now. We're ready to apply that to the flange on the rib. This can be done a lot of different ways. We detail in the plans putting sealant in a baggie and applying it that way. That works really well. I don't generally do that when I'm just working with one rib at a time and mixing small batches like this, because I just don't like to take the time to do it. I can apply it just about as fast, just doing it by hand. Or if you have a Semco dispenser gun and you're using the SemKit tubes that we sell, then you're going to have a larger amount of sealant that you're going to be trying to get through in one work session, and you'll probably be using a Semco dispenser, so then you can just be dispensing a heavy bead on the flange and then finishing it out with the popsicle stick. If you do use those, I recommend that you have some place to put them in that's cold between ribs. It'll just help you with work time on the sealant, because particularly the first ribs that you do, it's going to be a little bit of learning curve and getting up to speed with it, and it will take some time. So if you use that method, even using the bag, get some applied to a rib and then put it in a freezer or at least a refrigerator and get it cold, and that'll slow down the cure a bit until you're ready to bring it out for the next rib. If you do that, it's good to bring it out a little bit in advance so it can start to warm up, because the cold can also stiffen it up and it's a little bit harder to work with if it's not at room temperature anymore. So this is going to be pretty much identical to what I did earlier, applying the sealant to the angle stiffeners for the bottom of the skin. And I just keep touching it, and it kind of attracts to the flange to where you can just pull it and keep pulling a long string of it to lay it out. And then once we've got some on the surface, we can trowel it out a little bit to make sure that the entire flange area is coated. And then I'm gonna finish the shape of it with my stick tilted a little bit, kind of angled like a plow so it doesn't run off the side. Just start that on the back side. Then on the outboard edge, that's about the same as what we had on the stiffeners. I like to put a little extra blob right here on this tab that's all by itself, or if you've got a rib that's got a couple of those, to just make sure that it's not gonna be a little bit lean, depending on how the rib fits or nests in the leading edge of the skin. Okay, so we're ready to insert that. Get my boost box. So I like to hang on to the nose end, so I've got better control. It doesn't end up moving around as much. And then I try and just watch the top edge and keep it as close as I can, but not touching as I lower it in. The sealant is sticky enough that once you get it into place and it touches, as long as you've got the flange aligned with the holes, it's going to kind of stay there. Then you can do some hard push, engage the nose all the way into the leading edge. And then I start with the aftmost hole because it's the easiest to find and get lined up. Because all I'm trying to do initially here is just establish the relative position of the rib. And that allows me to even angle the cleco a little bit, go up and find the hole. And then we'll start at the opposite end and be working to make sure that we've got everything lined up with all the holes. So I'll go up to about the third hole or so. Do some massaging up and down. And while I push, make sure it fully seats in the leading edge. And then cleco. And then I'll cleco about every third hole, so skipping 2. That will allow us to do about 3 holes at a time till we get further up here than it'll even be before, or at least loading multiple holes with rivets so that they're all being shot sequentially before we have to remove another cleco. So then the same on the opposite side. pushing down, making sure we've got it centered up on the hole laterally and fore and aft. Click on every third hole. So we get up there where it's flatter, and then skipping 3 is fine. So now we've got the rib in there, got it seated all the way forward. Because the rib is kind of broken with notches in the flange at the leading edge, it's not super stiff right in that area. So it won't necessarily align well with the holes, even if the rest of it is. So we need to confirm the alignment of these first couple holes. And that looks pretty good there. And that one looks pretty good. Occasionally, when the rib pushes all the way into the nose of the skin, it'll move the nose of the rib enough that you need to reach down into the bottom and push it one way or the other to bring those forward couple of holes into alignment. So if you're probing the holes and you can feel the ribs a little springy there, but it doesn't move over, it's because there's just enough drag in the rib, in the nose of the skin, that it won't let it move. And you can just reach to the bottom and just put some pressure on either side to move it just a little bit the direction you need it to go. So I'm going to re-clean these holes just a little bit right in the front where I was probing to make sure the holes were in alignment. You don't have to have it absolutely perfectly clean. A little bit of sealant in there won't hurt anything. We just don't want the great big blob so that when the rivet goes in, it's really filling up the dimple and it will hold the rivet up off the surface of the skin. Okay, we've got the rib inserted, we've got the dimples cleaned out. So now we can load up some rivets. I just do the first 2 up to the cleco that we have, and there's gonna be enough sealant in the hole that you can insert rivets, and even when we're banging on one, the other ones will stay in, generally. I haven't had any fallout at all on this tank yet, but every once in a while one might, but it's usually enough to keep them in place. So once they're in there, particularly if you're a novice at this, I recommend that you make sure that it's somewhat cleaned off on the outside. Just a little bit of sealant there would be okay, but sealant is really slippery and slimy. And having that on the skin surface just makes it that much more difficult to control a rivet gun, because it's going to be trying to slide around and move on you. So especially if you're doing this solo, give yourself every opportunity to simplify it for yourself, and just take a little bit of extra time, keep that surface cleaned off, the surface on your rivet gun cleaned off. Now I'm using masking tape as a scuff barrier. Some people use plastic packing tape. I used to use that. I kind of got away from it because it sticks so well that it's very difficult to get off and move. And you need to keep moving the tape pretty regularly, because it does begin to wear through it. And if you go long enough that you wear through, then the tape tears into pieces when you're trying to peel it off. So I just started using masking tape a long time ago.
I move it really regular, and I put on an extra long piece. I can just peel it off, just move it over a 1/2 inch or so that you've got a new surface right in the center, and then just go back to riveting. Okay, so because I'm in the curved area down here, this is just a bar that we have that I've gotten used to using. I wouldn't go out and get a bar like this if you have other ones that you can make work. There's a lot of different bucking bars that will work, and it's somewhat a personal preference thing too. A curved one like this can be a little tricky, lining up and getting square on the rivet. I use my fingers to measure the gap on the 2 corners so that I kind of know what my alignment is. And then especially if I have a number of rivets loaded up, right now it's only 2, but sometimes it will be more, I use the bucking bar, push the rivet back out just a little bit so I can make sure I'm getting on the one that I've got the bar on. So then once we make our way up to the cleco, take that out. So again, I like to clean them off just a teeny bit. It just takes a couple seconds. And then if we've got a bunch of sealant in the hole where the cleco was, this one's not bad, but I'll still clean it just a little bit. Then we load more rivets. As I mentioned before, your gloves start to get messy, whatever. If you get a little bit of sealant on there, you can just wipe it off so you're not going to be making it more slippery. Now I'm getting a little flatter here so I can go to the flat side of the bar. So you probably notice we're working from the leading edge towards the trailing edge, because as I mentioned, there's a bit of gap just from the buildup of the sealant when the rib is first inserted, and we're trying to work that sealant out, except for just leave a little layer for actually sealing the rivet joint. So we want to work that slack of the skin from the leading edge to the trailing edge. If we started riveting at the front, we'd be kind of locking that gap in, and we'd be forcing the leading edge to translate forward of the rib. So always go from the leading edge to the trailing edge on the front and the back side. Okay, the very last or most aft rivet is one that can be a challenge even for me as long as I've been doing this, because there's a lot less stiffness in the rib flange because it's at the very back edge of the rib flange. You know, there's no continuation of material, so it's very flexible. And if I ever riv up or mess up any rivet, it's usually always going to be that one. So I recommend, if you have access to it, that you use a hand squeezer with a deep reach yoke This is a 4-inch, I think. And I always use a squeezer on just this one rivet. A 4-inch yoke is just long enough that you can just get the rivet under the edge of the rivet set. And then not have it messed up. So you may have noticed the cradle that I've got the tank skin sitting in for assembly. You can make this just by using the wing rib and tracing to get the shape, and then add maybe, you know, 1/4, 3/8 of an inch or so larger when you cut it out. That'll give you some room for a little bit of padding and just a little bit of play in there. And then just join the two halves together. Part of the reason for that is particularly when I'm working solo like this, I'm gonna spin this around on the work table so that I have access to the other side. So I just use a couple of the little quick clamps just to make sure it doesn't slide around on the work table. Oh, the other thing I meant to note is you can see this cutout, and that gives you access to the forwardmost rivets in the rib because it wraps around into the leading edge, and the angle you need to access with the gun, if you just left that full and had the edge of the table there, you wouldn't be able to get the gun aligned on the rivets. So with the opposite side, and it's not really critical which side you start with, but with the opposite side, it's just going to be a repeat of the other side. So I tend to alternate back and forth so that I don't have to turn the cradle as many times. So I just leave it how it is for doing the next rib and start with the bottom versus the top. The only thing that may influence your decision on that is everybody wants the airplane to look good, and particularly wants the top to look good. The riveting is a little bit different on a fuel tank with the sealant in there. So I recommend that when you first start, or maybe even start a work session, if it's been a while since you've been doing it, flip things around so you're starting with the bottom, so that if you do get a little bit of an oops, at least it's not in the top side, and won't be quite as frustrating, hopefully. So we got that rib in and fully riveted, and we need to now do the filleting on each edge of the flange like we did on the skin stiffeners that are in the bottom of the tank. I'm just using a popsicle stick that I've modified to a little bit tighter radius. The normal big radius is a little fat for these really thin flanges. So it's down to about a 1/16th radius, thereabouts, 16 to 3/32. This is a 3/16 radius on a normal popsicle stick. And just putting it at a slight angle so that it is dragging some sealant with it, and just finishing that out. To a little bit of a radius. If you have an excessive amount, which I wouldn't call this excessive, but if you end up with an excessive amount, you can scrape some of the excess and even move it to locations where you maybe didn't have quite as much squeeze out, like right up there at the top. That looks pretty good. I want to make a particular point of the aft bottom of the rib here. You'll notice that this notch is quite a bit larger than the one on the top. And there's a reason for that. At the very bottom aft corner of each rib bay, we want to try and leave a water pass through when the tank is finally fully assembled. So at this point, if you have any excessive sealant squeeze out, you want to make sure that you get rid of that right in that location, because we're going to add even more when the baffle goes in, and you'll be seeing when we do that that it leaves a bead of sealant in that area, and if there was already a heavy amount built up, it could potentially close that off. So you want to clean that out as you install each rib before the sealant cures. So then we'll go to the outboard side here. If I start getting a big buildup, I just keep a towel and wipe the excess off. Must have been a little thin right in this area. There's not a lot of squeeze out, so I'm just taking from where it's heavy and just troweling a little bit in there so that I can get a finished fillet along that part of it. So once again, I have my little piece of aluminum tubing, just kind of deburred on the end. And just put a small amount on it. It'll slowly build up with a bunch of sealant inside, where after you've been going a little ways, you can do 2 or 3 rivets without even adding any more sealant. There we go. Should make a ring around the perimeter of the rivet, and then totally encapsulate it around or over the top of the head. At this point, we've got all the intermediate ribs installed in the fuel tank. So we're ready to start working on each of the end ribs, the outboard and the inboard. They're very similar, but there are also some differences. We're going to start with the outboard one first. And one of the primary differences of it is it has a tooling hole from producing the part that obviously fuel will leak out of if we don't plug that up. That's the one that got plugged on the other rib when we added the doubler ring and put just a little bit of sealant right there. So this one doesn't have the doubler to cover it up. So the simplest way to fill that is a 3/16 rivet cut short. That matches the hole diameter. and we'll just be using a little bit of sealant and setting that rivet in the hole there. So we're going to apply just a very little bit of sealant here. We don't want to make a big mess and have it squeezing all over the place. So just a light coating. Is enough. And then once we're done, we'll be coating over the inside of it as well. So 3/16 rivet is pretty big. It's well above what anybody can squeeze by hand with a hand squeezer, and even a smaller pneumatic squeezer like this. So back riveting works very well since a large number of people have a C-frame tool and the accessories that come with it. That works really well for back riveting a large rivet like this. So I have it placed on the floor because when you're needing a lot of force, a really solid surface backing up the tool helps it work. I have a standoff here that comes with the tool so that it gets the rivet set up above the base so that we won't have interference of the rib flanges when I turn it over. And then this is an arbor that typically comes with the tool that is machined on the end, the same as any standard rivet set for a rivet gun. So you can fit a rivet gun onto that and back rivet with it. So that's a cup set for 3/16 rivets. And then the arbor, since it's only intended for back riveting, it's automatically just a flush surface on the end. Then I'll level up the rib, make sure it's square. But that will seal the hole really well. And then we're going to coat the outside of the shop head so it's encapsulated just like all the other rivets that we're doing. And that will take care of that hole. So now at the nose end, we've got a filler plate that's intended to help assure a seal of all the little notches in the flange that allow the sharp nose radius to form. So we have holes that we need to make sure are fuel proof. Nothing can leak to the outside. So we'll just be coating the entire surface of the plate with a thin coating of sealant to just seal the entire surface between the two, and then setting rivets in all those holes. And then once again, we'll encapsulate all the shop heads when we're done. Once again, the emphasis is a thin coating here. We don't want to have a great big thick buildup of sealant between the parts. So you can work to get it well coated. And kind of trowel it off to get rid of any of the excess. So I pre-cleaned all these parts off camera beforehand, just like everything else for doing preparation for riveting. So once again, because we have multiple parts here that we're squeezing together as the rivet sets, just like we did for all the wing ribs and skin stiffeners, I'm not worried about putting sealant under the head of the rivet like I just did here, because when the rivet sets, it's going to be compressing the two parts together and sealing the rivet in between those two parts. But then we'll still encapsulate the shop head once we're done riveting them together. So we've got some sealant squeeze out between the parts all the way around and here on the back. So that will give us a good seal between the parts in the vicinity of the rivet head. Got some squeeze through on the tooling hole that got naturally blocked by putting this plate on. So that looks good. We'll do our fillet along the back here. Since these shop heads are a bit bigger, using the piece of tubing that I was using won't work. If I made one up out of 3/8 diameter, that would be big enough to go over the rivet heads, but since it's just a few, I'll just do it this way. Okay, so we're ready to install the rib in the outboard end of the fuel tank now. One of the big differences with the installation of the end ribs versus the intermediate ribs is, as you can see, the fuel is going to be on the interior of the tank against the main web of the rib. So if the seal of the rib to the skin is performing as it should, there shouldn't ever be any fuel getting to the rivets. So with proper application of the sealant, we don't really have to have sealant at the rivet dimples in the skin and the rib. So we're going to be applying a heavy bead of sealant along the edge of the rib towards the interior side of the rivet holes. That's going to squeeze towards the inside, and then we're going to be forming a big heavy fillet around that corner, all around the interior. And if all goes as planned, we'll have very little get out into the area where the rivets are and have any mess, towards the outside of the tank on each of the ends. The one area that's not true is going to be here in the nose. We're going to have some that's going to, because it's a broken flange, we're going to have some that squeezes out through the notches in the flange, and we'll be finishing that out and cleaning that up at the end. So let's get some sealant applied. So once again, I'm just kind of touching and dragging as I was on the other ribs, but I'm biasing the bead of sealant towards the inboard edge
of the flange. Once again, if you're using the Semco applicator with one of the pre-mix cartridges, it makes this really quick and easy because you can just lay a bead around the whole perimeter pretty quickly. I'm showing you this way as a way that it can be done if you don't have anything else. I'll be using the Semco applicator when we put the rear baffle in, because that works really well for what we need at that time. Okay, an RV8 tank that we're doing right here, this is one of the most difficult ones to accomplish this at the outboard end rib, because it has just the little short bay, which doesn't allow opening the skin up very much. It's a little easier on the other tanks that have a full-size bay. That rib's far enough away that it lets you spread it apart a little more. And I missed a little bit on this side, so I've got some sealant towards the outside, more than I would like, but that's not the end of the world. It just means a little bit more cleanup. So then we'll do the same as we're doing on the other ribs. We'll get a Cleco inserted near the back. Use that to start pulling the rib down in. That's ideally how it would turn out. At the bottom of the rib, there's a big bead that squeezed through to the inside that will be a good amount of sealant for making a real generous fillet there. And on this side, there's not as big a one because I smeared it a little bit. All that means is I'll just have to be applying a little bit of sealant around that corner as I finish the fillet. So there you can see the beads of sealant squeezing through that I talked about. That's going to be a good indicator that you had enough applied to the nose portion of the tank. Once again, because of the big fillet that we're going to be putting on the inside, if you don't have a large amount squeezed to the outside, not a big deal, because we can apply more on the inside and finish it out with the fillet. So we got the end rib installed in the skin now. So you can see I just cleaned up a little bit where we had the squeeze out at the gaps in the flange at the nose. it's important to clean excess sealant that squeeze, if you do have any, that squeezes out to the outboard side of the flange, because the splice strip that's on the other half of the leading edge of the wing that this end of the tank screws to, that reaches nearly to the rib, and if you have an excessive amount of sealant sticking out there, that will affect the fit. I didn't do it for this one, but what you can do to keep things a little bit cleaner is, prior to inserting the rib, you can put a strip of masking tape down that will be right adjacent to the rib, so you can pull that tape to pull any excess sealant that squeezes out, and then there's not as much to clean up. I didn't have too much, so it wasn't too big of a deal. And once again, to reemphasize, we're sealing from the inside to the outside. So you'll notice I haven't encapsulated these rivets. There's no point in taking the time to do that or coat that with sealant if we've properly sealed the rib and properly finished with a fillet on the interior side, which we'll show you here in a moment. That's stopping the fuel progression from moving through that gap that would be there on the rib on the interior side, so nothing ever gets to where those rivets are. So there's no sense in taking the time to seal over all those rivet heads. One other thing I'll mention is right here where I'd sealed that tooling hole with the rivet, I went ahead and put sealant on that ahead of time because I had forgotten how annoying that can be, especially working on the RV8 tank in this small little space. Then I ended up getting sealant on my arm. So as long as you make sure that you don't forget to do that before you close up the tank with the rear baffle, and we'll be doing kind of an overview inspection right at the end before we do that to make sure everything is right, then you don't have to deal with sticking your arm down in there and getting sealant on you. So we're preparing to put the last rib in. This is the inboard root rib of the fuel tank. Has the access hole. It's got a hole for a fitting that's going to be attached to the vent line in the tank. And it has a support bracket that interfaces to the fuselage for support of the fuel tank. Other than those three things, it's pretty much identical to the rib that we already did. It's got a doubler that's on the inside that will be fitting prior to applying the sealant and putting the rib in the tank. Now, the one thing to keep in mind with this bracket that goes on here is it will block access to setting these rivets. So we don't want that in place when we put the rib in place, but it's most optimal to have the doubler in place. So to avoid having it too big of a mess and struggling with getting things lined up, I've gone a little off plan here with just a tip that you can use that helps get things lined up and holds parts in place while you're going through this process. I've drilled a couple of number 40 holes in the middle of the rivet pattern that's detailed in the plans. Made sure that I have good edge distance on all the parts. And those have been lightly machine countersunk for some NAS 1097 rivets. And I'm going to use those two rivets as keeper rivets just to hold the doubler plate in place with some sealant between the parts while I put the rib into the wing or tank skin and then get it riveted in. And then once that's all done and I've done the filleting on the inside, Then I will come back, add a bit of sealant to the bracket, put the bracket in place, and set those 6 rivets. And that'll avoid the interference problems that we would have. Then at the very end of the work for this rib, we'll be installing the fitting for the vent line, which is already in place in the tank right now, because it's a lot easier to get in there when this rib isn't in place. And the reason for saving that to last is the fitting protrudes inside of the tank, and that will be in the way for forming the fillet along that corner. So if we save that till last, it makes it really easy to finish that. So we'll show the finished details after the rib's installed. So we've completed the installation of the inboard rib now. We've got the filleting done, the support bracket riveted on, and we're ready to move on to installing the fitting for the vent line. Once again, I mentioned earlier that we left that off so that we had easy access around the interior of the rib to complete the fillet. We'll give you a close-up view of that again so that you've got a good idea of what we're looking to accomplish there to assure the seal from the inside out. And if you look here on the outside, once again, I've got the skin good and clean. The little bit of squeeze out that I had, it was a small amount. I did a little better job inserting the rib on this side, but I cleaned all that up. That's eventually on a lot of the models going to have dimpled holes with nut plates for winglet fairings, so you don't want big globs of sealant sticking out beyond the edge of the rib flange there. Okay, we're ready to install the fitting in the root rib bulkhead for the vent line. So I've cleaned the surfaces on the bulkhead, I've cleaned all the parts, and just need a small amount of sealant. That's going to be the surface that contacts the outer surface of the rib. And then we'll put a bead around the washer. Once again, these are going to be net fitting parts, so the majority of the sealant you apply is going to squeeze out when those come tightly together. So using a whole bunch is pointless and just adds to the mess. So that's going to be more than enough. And then we'll add a really small amount just as some extra insurance on the outside once the washer's on the fitting before we put the nut in place. Okay, so we got that fitting in place. We can hook the line up to it. I
use a backup wrench on the fitting itself. Tighten up the line. All right, now that we've got the fuel vent line fitting installed and the vent line connected, we're ready to start closing out the fuel tank with the rear baffle. Before doing that, want to make one more look through, make sure there's nothing inside. Haven't left any masking tape or anything that you maybe put somewhere for some reason. Double check our positioning on the vent line at this end, that it's in the retainer that's riveted to the fuel cap flange, and that we've got a little bit of gap. It's not stuck into the corner, going to be blocking it. I've gone through and done cleaning of all the parts where we're going to have sealing surfaces and having sealant applied, so that's ready to go. Just to back up something that was talked about earlier and re-emphasize it again, is we want to avoid excessive use of sealant. This is some parts of the assembly that with a lot of sealant buildup can cause dimensional changes of the fuel tank. As an example, if we've got a thick buildup of sealant on this flange, then we put the baffle in place, then another thick buildup of sealant under the Z-bracket. That's dimensionally changing the overall core dimension of the tank, and when those Z-brackets bolt up to the wing spar, it's going to be pushing the leading edge of the tank a little further forward than intended. So as we apply the sealant, you're going to be seeing me be very particular about using just small amounts in places that we don't need a lot. If all we're sealing is just a small little rivet hole, it doesn't take a 1/16 inch thick coating of sealant on there when the baffle goes into place to accomplish that. We're just going to be using a small amount. The critical place to keep this in mind is right here at the bottom of each aft rib flange. If you notice, there's a difference in the gap produced by the corner at the top and the bottom, and that's designed that way on purpose so that once the baffle is installed, we're providing a flow path between rib bays with the dihedral angle of the wing, so that any water entrapment and sediment that can't get past because of the height of the rib flange and the corner edge of this flow-through opening here, that there's still an opening there to assure that there can always be flow from the high side to the low side all the way down to the corner where the fuel drain is located, right here in the tank. So particularly along the bottom of the tank where the baffle interfaces, an excessive amount of sealant there will end up pushing forward and blocking those openings. Because we're installing the baffle blind, we won't have a view of those points once the baffle is in place. So it's not even easy to inspect whether you have blocked those locations or not. So we just need to use care in the application of the sealant. Okay, we're ready to start applying some sealant. As I mentioned before, we want to avoid adding excess buildup of sealant between parts. So because the baffle goes in place on the back for this particular tank, and then there's a Z-bracket that goes on the baffle. We have the opportunity to seal between the Z-bracket and the baffle. So that means there's no point in adding sealant right here on the interior side of the tank when there's other points to seal working from the inside to the outside. So the only place I'm going to be applying sealant on these ribs is just a small amount at the outboard holes, because the only thing in that location is the baffle and then the rivet that comes through the baffle. But notice I'm keeping it pretty thin. And then we'll also be putting a little bit of sealant on the rivet for those locations when it gets installed. So we're adding some sealant on the outside surface as well. Okay, we're ready to continue applying sealant for the installation of the baffle. This next part that we're going to be doing is going to be applying a bead that's meant to be strategically located so that when the baffle gets pushed into place, it's actually smearing the sealant and providing a seal at the interface point all around the perimeter. Once again, just like the installation of the end ribs, we want the seal of the baffle to the aft flange on the end rib to primarily be along the corner of the flange bend. So I'm going to be applying sealant inboard of the holes, because we don't really need sealant at the rivet holes if fuel is sealed to the interior of the tank and can't get past this point. That keeps the tank cleaner on the outside. It'll be much less of a mess, you know, installing those rivets. And then we're going to be continuing that line, you know, all the way around the circumference, and then putting the baffle in place. Now, because gravity works for us or against us depending on the position, notice I've got the tank sitting up on my support stand here so that the bottom is down, and I can apply a bead of sealant down the length, and gravity will let it spend a little bit of time settling and sticking to the surface. Then I'll be flipping it over so that I can do the other side, so that I'm always using gravity to my advantage as I lay down the bead. The bead we want to use is in the order of about 3/16 diameter. So you can't even bring an AN bolt out and lay it here to use as a reference, you know, to kind of eyeball how much you're putting on. I've loaded up a cartridge to use a Semco applicator. This is the nicest way of doing it. But once again, using the baggy method, you know, with the corner on the bag cut, you can apply a pretty nice bead that way also. I recommend you just mix up a little extra sealant and just spend a little bit of time practicing. Just lay a bead down on some cardboard or something just to get some practice, because ideally we want to try and get a nice, consistent, unbroken bead down the whole length of the skin. If you have areas that it gets to be a real heavy buildup, particularly right where each rib is, we have the risk of pushing all that sealant towards the interior and blocking those corners. If it's too light, then you have the risk of not getting a good seal in that location. Over the years, working with customers with tank problems, I would say that 90% of the leaks that people end up having after constructing their tanks are usually related to the baffle installation. Because we're having to do this blind and you're needing to apply sealant to assure a seal without having the opportunity to go back there and, you know, retool it on the interior. I've maybe built 20 sets of tanks over the years, and I've had one leak one time, and it was related to rear baffle. Fortunately, right here in the outboard corner that I had access to through the fuel filler hole, and I was able to make a repair that's lasted for 20 years now. But so this is the most critical part of the assembly, that some care with the application of the sealant is worth taking your time. So don't rush, and look it over very carefully after you've got the sealant applied to assure that, you know, it's a good even bead around the perimeter and there's no breaks in it. So let's go ahead and start here. We're going to be adding a little bit of extra right here in the corner because there is a corner notch on these ribs that we want some continuity between the bead we lay down and the bead we lay down on the skin and the one that's on the rib flange. And then the idea is put down a bead just inboard of the rivet holes. So that we don't get any squeeze out there. And have mess to deal with. But a bead that will be tall enough that as the baffle slides into place, it smears the sealant along the surface of the skin. Back up just a little bit right there. And once again, I'll make sure there's a good blob there that's going to close out that corner. Then just before we put the baffle in, because that can tend to sag in a little bit, we'll apply just a little bit more there and then immediately drop it in. So now we're going to flip over. Because the bead that we just applied is now hanging vertical to gravity away from the skin, it shouldn't sag or run out of position. It should pretty much stay right where it is. And we can do the other side. Because the top side doesn't have the open corners to provide for the drain path, I just went ahead and started with how I had the tank sitting. But to give you an opportunity to get a little bit of practice, it probably would be better to start with the top side of the skin because this is less critical. Okay, so now we've got the tank turned leading edge down, and we can finish the beads on the two end ribs. Once again, like I described, we want to concentrate the application of it to the inboard corner. And make sure that we bridge well to the bead that's on the skin. And you can see this one is starting to sag a little bit over here just from the weight. And that's why just before the baffle goes in, we'll be doing a little bit at the corners to supplement that and make sure to get a seal. Okay, so I'm looking the whole thing over, making sure that we have no breaks in the bead. I have noticed a couple of places where I maybe got a little excessively far inboard of the rivet holes. Here's one zone right here to where when the baffle goes in place, it may not get a good smear on the sealant. So I'm going to go back and just add just a little bit more. So you can see the sealant kind of sticks to itself really well. So if I'm just applying a little bit along the edge, it'll just be grabbed by what's already there. And if you have an understanding of, our goal to not block these openings, you can see that adding a little bit excessive amount of sealant out in the middle of the rib bay, that's not going to have any influence on that. So I don't need to take quite as much care here. You just really want to pay attention that we don't have an excessive amount right where each rib is located, but we have enough just beyond the hole that it's going to get a good smear so that it seals. Okay, so I'm happy with the bead all the way around. I'm going to just make sure these corners are pulled up. This one started to sag inside a little bit. And those all look good, but I'm just going to add a little bit more right in this corner. And then we don't want to waste any time with it sitting that way, because now gravity is working against us and those beads are wanting to sag to the inside. So we'll get the baffle put in place right away. You can use your fingers at one end to line the end up with the edge of the flange before you drop it in place. then bring the other end in place. And we'll go around and cleco at all the holes that have been left unmachined countersink as described in the plans. So that we've got something to assure good hole alignment. So now I'm looking down the length of the baffle flange and just looking for areas that haven't pulled up all the way and just fitting a few more clecos. Just to assure that we get good contact between the baffle flange and the skin. And if everything has gone well so far, you can look inside of the access opening there on the root rib, unless it's a RV10 or RV14 tank, there's no access. You can see the bead squeeze in the corner. So we've got the baffle in place now, all clecoed along the flange edges. So now we want to install rivets between the baffle and the ribs where the Z-brackets aren't located. Unless you're building a tank that has no Z-brackets, then you could do all of them. But just where the Z-brackets aren't located, just use those rivets to assure that it pulls the baffle fully tight onto the rear flanges of the ribs. And then we'll move on to riveting the flanges to the skin. So each rivet and the rivets used on the interior areas of the baffle are a special closed-in blind rivet that won't have an open path down the center, so they just get a little bit of sealant applied to them. And if you spin it slightly as you insert it, that'll assure that it's fully coated under the flange of the rivet head. And that's what we're using primarily to gain the seal of those holes, which once again is why we don't have to have an excessive amount of sealant applied on the inside. Okay, we'll set the blind rivets. I prefer to have an air setting that doesn't really slam the tool. I've got the air pressure turned up high enough that it'll just pull the rivet. So it gives it a little bit of time to bring the parts together tight and then break the stem. So I think with this tool, I'm somewhere between 40 and 50 psi. Okay, and then we'll also add the solid rivets. On the two end ribs in the holes that don't share holes with Z-brackets. That'll once again just assure that the baffle's fully pulled tight to the rib flanges. Okay, we'll get the N470 rivets on the end baffles set. Okay, that takes care of assuring that the baffle is pulled tight on the aft flanges of all the ribs and should assure good alignment of all the rivet holes in the baffle flange. And now we can move to installing rivets in those holes. So to make it easy, I'll be flipping the tank up on the stand again so that the rivets are dropping in vertically and they won't fall out. Okay, got a few rivets put in, so let's go ahead and set those using a pneumatic squeezer. You can use this or a hand squeezer. Drive them with a gun and a bucking bar as well, but I think this is a lot better choice and much lower risk doing any damage. And as I'm moving along here, I'm looking to make sure that it looks like the rivet's laying down pretty flush. If you find one that wasn't countersunk quite enough, you can just skip that one for now. And later on, when you come back to machine countersink the holes that weren't done previously, you can just touch up the ones that you left open. So continuing to work on the rivets on the baffle flange to the tank skin here. Got some more loaded up and ready to set. Just wanted to emphasize that the riveting that I'm doing right now is important to complete once the baffle is put in place, and the sealant will continue to cure from this point on. So we want to get all the parts riveted and nested tightly together. That is one of the specific reasons that we did not put sealant between the baffle and the rib flange where the Z-brackets are going to go, because they're not going to be riveted immediately. That sealant would begin to cure and possibly have some gap from the sealant buildup. The benefit of that is it allows you to break up the riveting sessions into separate projects. So we can finish the riveting on the perimeter of the baffle now at this point, and we don't have to install the Z-brackets because there's no sealant under the baffle that we need to get compressed by the riveting process. So you need to go through and finish the riveting of the perimeter of the baffle, with the exception on the ends of the 5 holes that are going to be common to each end Z bracket. But loading that up with Clecos, if you're gonna leave it till later, should be sufficient to pull that tight together. Then finish riveting the rest of the perimeter, and then we'll be doing the Z-brackets as a separate project afterwards. So we've got a good majority of the rivets in the perimeter of the baffle now, except for on the ends where the Z-brackets will go and where we've got some Clecos. We're gonna take a little pause from the riveting, just like you may have to at some point. Because the sealant is still pretty fresh and it's still within the working time, it can still flow and move a bit. So we want to use gravity to our advantage in getting it to flow back to the corners if possible. So while I'm gonna not be working with the tank, I'm gonna turn it up with the baffle downward so that it's sitting that way. And those beads, instead of continuing to flow down the surface of the skin, they'll have a tendency to stay more near the corners. And then we'll be able to come back and finish the riveting where the holes are still filled with Clecos and the few that aren't machine countersunk yet. So we've completed the riveting of the rear baffle. All the rivets are in around the perimeter, with the exception of these 5 for the outboard Z-bracket that still needs to be installed. I have installed the inboard Z-bracket, which is just basic riveting with 1/8" 470 rivets. And I've installed 4 of the other Z-brackets just to have them in place, since we really only need to demo just this one, and then we're gonna get this one installed now. So start with, once again, making sure the parts are clean, like is normal for all the rest of it. And then gonna emphasize again, small amounts of sealant. It takes very little. And I'm putting it just at the point that we need to prevent a leak from happening, which is out through the hole that's in the rear flange of the rib and the baffle. And I'm even gonna skim these off a bit. Keep in mind the fact that when these rivets pull tight, it's basically a net fit of the Z-bracket to the rear baffle. So there's not much room there for any sealant. And if we have a lot, it's sticky and viscous enough that it's not going to be able to squeeze out of that area. And you're going to be having a buildup that's changing the relative position of the Z-bracket off of the baffle. So that may not look like very much, but you'll see in a moment that we'll get squeeze out all the way out off of the edges. So then I grab a couple of rivets so I can insert them before putting the Z-bracket in place to help me get it aligned. I didn't really show much detail when I put the other closed-end rivets in, but what I do is try and work to just get sealant on the circumference of the rivet. We don't need a big blob on the end. That just pushes through to the inside, could potentially break away later. So the way I do that is whatever surface I have my sealant mixed up on, just put the rivet down tight against it, and then I'm just turning it through the sealant, so it pretty much is just putting a coating on the outside, and that's even a little more than we need. So you see it gets a little bit on the end of the rivet, but there's not a big bead or blob on it. It's mostly just around the circumference. And then as I insert this, you see it wipes most of that down the rivet and leaves it under the head. And then there's only just a very small blob there. In this case, probably what was in the hole from when I wiped the sealant on to the Z-bracket. So here I'll do another one. Put that in the opposite end. See, then there's not a big blob on the end. Now that gives me a couple pins. To line the holes, and I don't end up smearing the part all over. Since we don't have a lot of sealant on there, we don't want to smear it all over the back of the baffle. Then it just drops in place directly over the holes. So once again, I'm just putting the rivet down tight against the surface, and then I'm moving it sideways to just bring it up next to where there's some sealant that as I rotate it, it'll gather it onto the end. There's no sense sticking the rivet in the blob and having a huge blob on the rivet and sticking it into the hole, because 95% of that sealant is going to be to the outside of the rivet, and it's going to be all over your tools, all over the back of the tank, and not doing anything for helping to seal the hole. And then as I showed before, as I'm bringing them down, I'm just rotating it a little bit just to make sure what sealant is under the head gets distributed around the full circumference of it. See, that one's got a little bit more on it than the others did, and you can already see how much that's squeezing out. If I just stuck the whole end of the rivet into the sealant, had a big blob on there, there'd be a big mess all over that. And that one doesn't look like there's much, but if I lift it up, you can see there's sealant all the way around under the head of the rivet. That's all we need. So now setting these rivets, because they're so close to the Z-bracket, it can be a challenge getting a regular rivet pulling tool in there, whether it's a pneumatic one or a hand-operated one. RV12 builders will be familiar with this tool because it's a recommended tool for the 12 kit because they use so many blind rivets, and it has a really tight access to vertical flanges that are beside a rivet. So as you can see, I can get that, down on there, and I've got enough clearance. So if you can find an RV12 builder that's got one of these, you could borrow his. Otherwise, I'll show you another technique to use. So as the rivet's set, you can see a little bit of black from the sealant squeezing out around the perimeter. That's really all that we need. The rivet's set solid, and there is sealant underneath of it, and there's a little bit of sealant between the part around the circumference of the hole. There's even a little bit of squeeze out here on the side that even with the small amount of sealant that is in there, it spreads and distributes pretty widely. So using the small amount is the way to avoid adding dimension that throws off the size of the tank. So for one of these other rivets, here we'll use something that we detail in section 5 of our construction manual, making a little wedge. And what that does is it allows us to put it in place over the stem and angle the wedge away from whatever is going to be causing an interference. So we're actually going to flex the stem over at an angle, but you can see on the bottom of the wedge that's nearly parallel to the Z bracket, so it will still properly form the head of the rivet because it's got something squared up pushing against it. Then the head is set without being tilted over to the side. Don't attempt to set these just by pushing the tool down on it and forcing the rivet over to one side. The rivet head won't be seated flush on the back of the Z bracket because it's going to reform the head to match the angle of whatever the tip of the tool is. So if you're using a tool that has to be tilted over, you really have to be using the wedge. So now you can see we've got sealant squeeze out in the zone of each rivet on both sides. Now that it's sat a little bit and it gave it some time to extrude out of there. So even with that really thin little coating, it's fully sealing the zone of each rivet all the way through to the outside. Okay, we're ready to finish up with the last Z bracket here. Because of the really tight spacing of the rivets to the fore and aft web on the Z bracket, it's difficult to get on that with a rivet squeezer. So I'm going to finish these up just with a rivet gun and bucking bar. We're finished with the main assembly process of the tank at this point. Just wanted to highlight one other thing that I hadn't yet. Once the rear baffle was riveted in, I've added a little bit more sealant in the corners here on the outside, just as some extra insurance. If there was a sufficient amount of sealant there when the baffle was put in place, it squeezes out and leaves a bit of a bead there and should be sealed, but you can add a bit in the corner and fillet it slightly, push it down into the gap between the baffle and the skin, just as some extra insurance. So on all 4 corners. The tank should sit for probably 2 to 3 days minimum before doing any pressure testing. That's going to be very dependent on the temperature also. That period of time would be if it's normal room temperature, 68 to 70 degrees or so. If you're leaving it in a cold shop, I would leave it a bit longer, maybe even a week if it's pretty cold, and then you can do some pressure testing. It's best to flip it baffle side down as soon as you're done. Just like I mentioned earlier, that if you do have a pause from putting the baffle in, put it baffle side down, especially if you're still within the working window of the sealant. It can still creep some, and then we're using gravity working for us to move that towards the baffle instead of creeping down the surface of the skin. Okay, so we've wrapped up the construction of the fuel tank, other than some of the accessory parts that have to be added, such as closing out the inboard end on tanks that do have an access cover there. The quick drain, a few other minor things. Those will be covered with another video in the future. But just to highlight a couple of things regarding the construction of the tank, again, emphasize don't overuse tank sealant. It just adds weight, adds to the mess, because the more sealant you use, as I mentioned before, when the parts fit very tightly together, the majority of it's squeezing out where those parts are mating together. So that just means more sealant that's spread around all over everything, on your bucking bars, on your tools, just making a big mess. I understand that there can be a tendency to be very generous because nobody wants a leak and you want to make sure that it's sealed well. But just keep in mind that when you're bringing two parts that fit closely together, there's only going to be a sealant layer of a few thousandths of an inch in there when it's assembled, and everything else that you put on is going to be squeezed out, and it has to go somewhere, and it'll get all over everything. Another thing that I wanted to mention that I hadn't up until this point is allowing for a full cure before you do any testing. I just gave a general outline of a couple of 3 days at room temperature. Everybody's shop is different depending on the time of year and where they're located in the world. So a really good thing to do at the end of the build, primarily meaning the sealant that was used to install the Z-brackets, particularly if that was done as a separate work operation at the end, save a sample of that sealant, because that is going to be the most recently mixed sealant that you did, and just save that and keep it with the tank in whatever environment you're storing the tank in during that time that you're waiting for it to cure. Then you'll be able to use that sealant as a benchmark for whether it seems like it's fully cured. If it finally gets cured well enough that it's not feeling sticky, if you stick your finger on it, then you're good to go for moving ahead with leak testing. So here's a view of the inside of the tank, showing what level of squeeze out we had on the baffle flange to the tank skin. This is looking at the bottom aft corner of the rib at the inboard rib bay. You notice there's still a generous opening there for flow through for any water, sediment, and little bit of leftover amounts of fuel in a particular bay, allowing it to move downhill on the dihedral angle to the next inboard bay. So that's an example of what we're after. Try and make sure that you get full performance out of your tank. Okay, that wraps up the construction of the RV fuel tank. This hasn't been a comprehensive video that's been, highly detailed step by step, but we've tried to put enough content in it that it gets rid of some of the mystery that would be there for somebody that hasn't built a tank before. And we hope watching this ahead of time will just give you a little bit more confidence as you move into that project. So have fun building your RV fuel tanks.